Hello everybody. Taking a look today at 13.3 reteaching worksheet where you're going to talk about radian measure and what is a radian and how do you work with it. So if you take a look, notice it says a central angle that measures pi radians intercepts an arc that forms a semicircle, and therefore it's a 180-degree rotation from the initial side to the terminal side, which you just talked about in that last lesson with coterminal angles and all that kind of stuff. When converting radians to degrees or degrees to radians, you just use the proportion. So there are taking whatever your degree measure would be out of 360, and that equals whatever the radian measure would be out of 2 pi. Okay. First thing you need to understand is what a radian is. There's two ways to measure an angle. You can measure an angle the way that you have always done, and that is with the degree measure, okay, if you're working your way around a circle. So for example, if you take a look at this picture, I can measure that angle as a 60-degree angle, or if you follow it out and you remember back to arcs, if I were to go through and I were to talk about like this arc length right here that goes along with that 60-degree angle, that length would be the number of radians that it has, okay? And that's the idea of what a radian is. It's really just an arc length around a circle. So you can either measure an angle by the degrees of the actual angle or the arc length, and that's what a radian is. And the first thing you're going to be doing is going back and forth between how many degrees is this number of radians. And what you will find is halfway around a circle, 180 degrees, is pi radians, okay, so 3.14 radians. And all the way around a circle is 2 pi radians, or 6.28 radians, okay? I would highly suggest, if you have not yet watched the video link from the unit circle, I would highly suggest you do that from Monday, I believe it was, and that should help clear some things up as you work your way through this as well. But the idea of a radian, if we take a look, so they ask you what's the radian measure of a 225-degree angle. So we're just using our proportion to convert it. All we're doing is, if you think about like converting inches into feet or centimeters or yards or something along those lines, that's all this is too, is you're converting degrees into radians, okay? And you're just using a proportion. So 225 degrees out of 360 total degrees in a circle is going to equal how many x number of radians out of 2 pi total radians in a circle. Okay? The arc length, this goes back to the idea of circumference, all the way around a circle. Okay? And so once you get to here, now you just have a proportion. All you have to do is cross multiply to get an equation and then solve for x at that point. Okay? And in this case, you can go through and you can leave your answer just as a simplified version. You don't need to, you can go through and do both, would be fine. But so that's the first part. You're just going to be working back and forth between these two. Sometimes you'll be given radians, other times you'll be given degree measures, and you're just working your way back and forth between those two. Okay? Remember, biggest thing, a radian is just an arc length. It kind of deals like with circumference. So here's some problems to have you work on with that. And then on the back side, here's why we did special right triangles, why we were talking about those. We're going to be taking a look at finding the exact values of cosine and sine and tangent and things along those lines. So if I want to find the cosine of pi over 3 radians, one of the things I need to figure out is, well, what is pi over 3 radians? How many degrees is that? So if I do my conversion, what you'll figure out right here is that pi, remember, is 180 degrees, so just made a quick substitution there. And 180 divided by 3, that's a 60-degree angle. Pi over 3 radians is 60 degrees. So what you're looking at is actually this right triangle right here. If we're working our way around this unit circle, there's my radius of 1 that makes it a unit circle. I know I'm dealing with a 60-degree angle, and if I turn this into a triangle, this now turns into a 30, 60, 90 triangle, and I can use those relationships. Okay? And so here are your 30, 60, 90 relationships again that we did the other day. And so if we go through and we use that, if I know that the hypotenuse is 1. Okay? Remember back to those relationships. The short leg is always half whatever your hypotenuse is. So that's why if this is 1, that's why the short leg here, across from the 30-degree angle, is 1/2, because it's half of that value. And remember that the longer leg, the one across from the 60-degree angle, is always whatever the short leg is, times the square root of 3. So in this case, 1/2 times the square root of 3 is just the square root of 3 over 2. Okay? There's kind of like a 1 sitting right out front here that gives you that. So you know that this length is 1/2. You know that that length is the square root of 3 over 2. And we can go through and take care of that. Okay? And if you remember back to the video when we were talking about the unit circle, remember that the cosine is the x-coordinate. Okay, so in that case, that's why it's 1/2. And the sine is the y-coordinate. So that's why the sine of 60 degrees, or pi over 3 radians, is the square root of 3 over 2. Excuse me. So the idea is to find out what those different pieces are, and then we can figure out the sine and the cosine of those. Okay? And that's exactly what you're doing down here. Remember, if you're going in a negative direction, that just means you're going the opposite direction around the circle. And when you draw in your right triangle, make sure you always draw it up or down to the x-axis. Okay? Always up or down to the x-axis. And go from there. Again, as always, if you have any questions, please email, please communicate with me, and I will definitely work our way through it. We can always chat on the chat in Canvas. Otherwise, I can always set up a WebEx call too if you need to, and we can work our way through it. Okay? Have a good day, everybody.